Let's write down some facts about the rank sum test. One nice feature is that it has no distributional assumptions. Now, we don't have really anything else to compare it to yet, but we will soon. What I mean by this is I don't start out by saying, oh, and the data itself has to be normal, right? I don't make any distributional assumptions for the rank sum test. It's okay if the data is normal, but it doesn't have to be. Also, outliers are not a problem. The rank sum test will give you the same answer regardless of whether you have an outlier typically. It's okay if you don't have outliers, the rank sum test will work, but if you do, still okay. Censoring is not a problem, right? Because the rank sum test has a way to handle that, okay? We've also said that the randomization or permutation distribution depends on the sample sizes, the sample sizes within each group, not the data itself, right? I said that if you tell me there's 100 data points, 50 in each group, I know everything I need to know to find the reference distribution. You don't have to tell me that the first person's outcome value was equal to 6.2. I don't need to know that. I only need to know that the ranks consist of the numbers from 1 to 100. We also have no problems related to the sample size. So big or small sample size is fine. Now, there are other tests out there for which you need big sample sizes. And so often people get it in their heads that the rank sum is for cases where the sample size is small. Now, it is true that the rank sum test works very well when the sample size is small, but it also works when the sample size is big, right? It'll work no matter what the sample size is. It'll work regardless. There are certain cases when you should avoid the rank sum or avoid something about the rank sum. When to avoid the rank sum. Well, the most important one is just when there are lots of ties. If all the data points are pretty much equal to each other, then ranking them is really not going to get you very far. Okay. Also, we might think about when to avoid the rank sum with a normal approximation for the reference distribution. In other words, when do you pretty much have to use the exact or approximate exact reference distribution? And the answer is when you have a very small sample size. So the rank sum test itself works great for small sample sizes because the exact method for coming up with a reference distribution is available. The problem is just that assuming that the normal approximation to the reference distribution is good enough does assume that the central limit theorem holds, which means the sample size can't be like 3 or something.